Hi guys, I hope everybody's having a good day, good weekend. I'm sorry that my video on Google Classroom has been silent. There's something wrong with my computer and they haven't been able to figure out what is wrong with it. So I am going old school and recording this on my phone. So sorry it's super zoomed in, but I'm doing the best that I can with how much technology and I don't get along. This unit you're going to really like. It's on coordinate geometry. I'm going to just kind of show you the assignment sheet, which you haven't been given yet, but it is on Google Classroom, which is how you found this video. But if you take a look, it's broken up into two parts again, just like Unit 2. We spent 2 days on distance, midpoint, slope. Now notice this Thursday right here, this is when 8th graders, we were on the field trip, so we're missing this day, which is what this video is about. And then on Monday when we come in, which is right here, if I know where I'm pointing, distance, midpoint, and slope. Again, we're just going to practice. It's a quick unit because then if you notice on Wednesday, you take a test. This test is super quick. I can't imagine there's going to be any issues with it, but that's why I'm doing this video, so I know that we are all on the same boat. Coordinate geometry, everybody really likes. This unit isn't hard. I keep saying this unit is just annoying because it takes a little bit of time, but it's not anything that's challenging. You learn 3 formulas. One of those formulas you actually already know, and then we just kind of go from there. There's no real way I can trick you on this unit because it's all kind of cut and dry. The only way I can trick you is if I use a word other than distance, midpoint, and slope, which I'm going to kind of get through as we go through this process. So you should have received a copy of these note sheets from me in class. If you didn't get a copy of it, go ahead and print it out just so you can follow along. This is going to go in your notes section, so if you wouldn't mind, let's go ahead and highlight your your title. And I am using the world's worst highlighter, but that's okay. So highlight your title. And then I want you to go down and highlight where it says, what is slope? Last year in Algebra 1, we studied lines very intensely for a long time. We studied all different parts about lines. And the word slope is a major important piece about a line. And hopefully you remember little pieces about slope. But the big thing that I want you to keep in mind is, what does slope actually mean? A lot of you are going to tell me slope is the rate of change, which I agree. It's the change in your y values over the change in your x values. But if I want to think about like a 13-year-old, I want to remember it a different way. So the rate of change is the way your values are changing, right? So it's the way the different angle your line is going to lean. So what is slope? It is the steepness of a line. Okay, slope is the steepness of a line. It's the slant of a line. It's the angle your line leans. Okay, so whenever you're thinking about going up a really steep mountain or steep hill, it's the slope of that hill. Okay, so when we were studying slope, we had a variable, and the variable we used for slope was m. And when you hear the word slope, you always think of a phrase: rise over run. That's huge. Okay, rise over run. You rise the mountain before you go across the mountain. You can't go across the mountain without going up the mountain first. And the last thing we learned about slope was a formula, and we're going to get there here in a second. So there is actually 2 different ways I can find the slope. Either I'm looking at a picture, which looks like this picture right here, or given 2 ordered pairs, which is something like this. Okay? So when I'm given a picture, I have to pick 2 points. So I'm going to pick 2 points first. And then I'm going to apply rise over run. Alright, pick 2 points and apply rise over run. So I'm going to go down to my picture down here and I'm going to pick 2 points. Doesn't matter what 2 points you pick, as long as they fall perfectly through the corners of your grid. So I'm picking those 2 points right there. And then if I apply rise over run, you rise and then you run. You can only rise and run. You can't rise, run, and then fall back down. You're going to count. You have 2, you rose, and 4, you ran. Okay, so m equals 2 over 4, which can be simplified to 1/2. Okay, rise over run. So that's the first way you can find slope. So now 2 ordered pairs. If I give you something like this, I don't give you a picture, but I just give you the 2 ordered pairs. How do I find the slope? Some of you are going to say, well, you can just draw a coordinate plane, right? But it's actually easier to use the formula. There's a formula for slope. Now, depending on your algebra teacher, you learned this formula either forwards or backwards. Doesn't matter, it's the same way. So the formula to find slope is m equals y1 minus y2 over x1 minus x2. This is the way that I taught it. This isn't necessarily the right way. You could also flip it and say y2 minus y1 over x2 minus x1. It doesn't matter which way you do it, so whichever way you feel comfortable with, go for it. This is the way I'm always going to do it, just because it's easier going in order. First y value, second y value, first x value, second x value. It's just easier for my brain. If you're used to using this because your algebra teacher did it this way last year, that's awesome, all right? So if I come down here and look at example 2, I'm going to do the slope formula, m equals, and I might even go ahead and highlight my x values in one color and my y values in another color. These highlighters are horrible. Look how tiny they are. Ridiculous. All right, so x1, y1, x2, y2. So I'm going to take my first y value, which is 0, minus my second y value, which is negative 4. So I have 0 minus negative 4, which actually turns into 0 plus 4. And this is all over my first x value, which is 2, minus my second x value, which is 10. So 0 plus 4 is 4. 0 minus 10 is negative 8. So I'm going to clean it up, and I'm going to say negative 1/2. Now, as a friendly advice, you always want negatives to be on the top of a fraction. So if ever a negative is on the bottom of a fraction, you're just going to move it up to the top. It makes life so much easier, okay? Especially when we get into harder math like we will next year when we move on to Algebra 2. So now I'm going to look over here at this third problem. So same thing. M equals first y value 5 minus second y value, which is 6, all over first x value, which is 4, minus second x value, which is 4. So now I'm going to clean it up. 5 minus 6 is negative 1. 4 minus 4 is 0. Negative 1 divided by 0? Undefined. An undefined slope, remember? If I draw a coordinate plane. An undefined slope is a vertical line just going up and down. Okay? Remember, when 0 is under the fraction bar, it's undefined. Just as kind of a fun way of remembering it. So hopefully you just took this first formula out of the 3 we're about to learn tonight, and you're going, oh man, that's easy, I totally remember it. If not, you just got to make sure you memorize it. It doesn't matter which way you use it, as long as you keep your 2's are stacked together and your 1's are stacked together. You're going to get the exact same answer. Okay? So now we're going to go down and we're going to look at distance formula. I want you to highlight where it says distance formula. What does distance mean? So when you think of the word distance, what does that mean to you? Okay? It might mean how far something is. Okay, it's probably the most common. How far something is from each other. The distance between point A and point B. I want to know how far it is. Another big thing people like to say is how long is something. The word long or length is used infamously with the distance formula. So if I'm talking about the length of something, I want to always use the distance formula. That's one of those trick words that I might see. So if you notice down here, here is the distance formula, and it looks super scary just because it's super long, and I'm going to put a thought crowd around it just so I know it looks that it's important. But if you take a look at it, notice the inside's x1 minus x2 and y1 minus y2. Hey, we've seen all of that before. It's in the slope formula. The only thing that's different is I'm subtracting the x values and squaring it, and then I'm subtracting the y values and I'm squaring it. I'm adding them together, and then finally I'm taking the square root. So the big thing about this formula is you want to always square root last. A lot of people want to square root before they add, but it doesn't work that way because when you add squared terms together, it's much different than just taking the square root. Okay? Now again, with the slope formula, if you like doing x2 minus x1 and y2 minus y1, you can do that here too. It doesn't matter. All that matters is you're keeping it in the same order. Okay? So we're going to take this formula and we're going to look at the first example. It says find the distance between points A and B for the line for the line segment provided. Round to the nearest tenth. I want you to highlight where it says round to the nearest tenth, because now I'm telling you how I want you to write your answer. Rounding something to the tenth means I'm rounding it to 1 decimal point. Okay? So the first thing I'm going to do is I'm going to write down my ordered pair. So I'm going to write down the ordered pair for A, which is -3, 2. And I'm going to write down the ordered pair for B, which is 4, -2. And then I'm going to come over here and I'm going to set up my formula. Because I see this ordered pair first, this is x1 and y1, this is this is x2 and y2. So I'm going to set up my formula. x2, which is -3, minus x2, which is 4, squared, plus y1, which is 2, minus y2, which is -2, so that turns into +2 squared. Okay? So yes, you can technically take your calculator, type all of this in, and hit enter. But most people that do that, there's a greater chance of you getting it wrong. So I just want you to be careful. So I'm going to do this in my head, because it's just PEMDAS now. -3 and -4 make -7. 2 plus 2 make 4. -7 squared is 49, plus 4 squared is 16. 49 plus 16 is 65. So now notice the square root of 65. Can I do that in my head? No, so that's where I'm going to use my fabulous calculator. If I know where the square root symbol is. Square root of 65. And you get 8.06, so that's 8.1 units is my distance. And usually the variable we use for distance is d. d equals 8.1 units. Now, do I have to include units? I'm not going to be super strict now, but I will be getting stricter as we go on. So you might want to start getting in good habits. Okay? So now I'm going to go and look at my next example. Sorry, I got to scroll so you can see it. Alright? If I'm talking too fast, make sure you're pausing the video and you're rewinding. So, okay, I'm going to do this one now. So the first thing I do is I write down my ordered pairs. So A is -5, 3. And B is 2, -6. Again, I see this ordered pair first, so this is going to be x1 and y1, and this is going to be x2 and y2. Okay? So I'm going to open up a big square root sign, and I'm just following the formula. x1, which is -5, minus x2, which is -2 squared, plus y1, which is 3, minus y2, which is -6, so that turns into +6 squared. So I'm going to show you in class the smart way of typing this into your calculator. So if you want to just work on it by hand for now, that's great. So -7 squared plus 9 squared, 49 plus 81. 49 plus 81 would be 130. I'm now going to square root 130. And I get 11.4. So D equals 11.4 units. Okay. So now what I want you to do is we're now going to go to the next page. And it says find the distance of the following. Write your answer in simplest radical form. Okay. So now, yeah, that's a typo. It says formal. You're used to me making mistakes all the time. So, okay, I want you to highlight where it says write your answer in simplest radical form. So what I mean by that, remember, let's go back to algebra. We're going to have a little algebra review here. Example, simplify the square root of 8. I need the biggest square root that goes into 8. Well, that's 4. 4 times 2 make 8. So I'm going to square root both of these. Square root of 4, 2. Square root of 2, can't do. So that's how I would simplify radicals. Okay, just as a little friendly reminder. So if I come over here, it says find the distance of the following. Alright, great. I'm going to open up my distance formula. x1, 3 plus 2 squared plus -5 minus 1 squared. So, okay, I have 5 squared plus -6 squared. So that's 25 plus 36. 25 plus 36 would be 61. Square root is 61. So now I need to take in my calculator and I need to find two factors that go into 61. So I'm going to do 61 divided by 3. I know it doesn't go into 2. That doesn't work. 61 divided by 4. 61 divided by 5. That obviously doesn't work. What about 7? I'm going to keep trying, but sure enough, nothing goes into 61. 61 is prime, so that's already in simplest radical form. I'm done. Okay? So I want you to pause this video, and I want you to try B on your own. When you finish, unpause the video, and then I will explain it as we go. Okay? So, set up my formula. Clean it up. I get the square root of 113, but sure enough, again, I can't simplify. Hooray, my life has been made easy. Hopefully you're doing all right, so we're going to keep just chugging along over here. It says, plot the following and determine if GH is congruent to CD. So I'm going to highlight where it says the word congruent. And I'm going to go ahead and plot my points. So I'm going to plot negative 4, 4, which is G. And notice when I plot it, I'm going to name it G, so my brain remembers that's G. And then I'm going to do negative 1, 1, and I'm going to label that H, and then I'm going to connect my dots. I'm now going to do the same thing with C and D. Negative 2, negative 5, and 2, negative 3. Oops, and I'm forgetting to label, and you can't see. So let's do C is going to be here, and D is going to be here, and I'm going to connect my dots. So my goal is I want to know if this is congruent to this. That's my goal. All right? So, when two things are congruent, what does that mean? That means they're the same. That means they're equal. But what does that mean? That means their lengths are the same. Oh, their lengths are the same. So if I want to know two things are congruent, oh, I'm using the distance formula. DF. Oh man, this problem's awful. I gotta do the distance formula on two problems. So I gotta come over here and I gotta go, alright, I gotta find the distance of GH, and then I gotta find the distance of CD. So, alright, I'm going to find the distance of GH, and then I'm going to make you find the distance of CD. So, GH, negative 4 plus 1 squared, plus 4 minus 1 squared. So, I have negative 3 squared plus 3 squared, which is 9 plus 9, which is then the square root of 18. So, I could simplify this if I wanted to, but because I'm just trying to show if these are congruent, I'm just going to circle this for now, and I'm going to go do CD. Okay, so pause this video and I want you to practice finding the distance of CD. So when you solve this, you should get the square root of 20. Notice the square root of 20 is not the same thing as the square root of 18, so I would say GH is not congruent to CD. Okay. So now if I look at the next one, it says find the length of AB. This word length is the hint word to use what formula? The distance formula. So you're going to find the distance formula of AB, and notice it says give your answer in simplest radical form. Okay? So you're going to pause this video, you're going to solve this problem on your own, and then I will give you the answer when we get to class on Monday. Last formula. Woo! Midpoint formula. We've used this word midpoint before. What does midpoint mean? Midpoint means the middle of a line segment. What else does the midpoint mean? It means the center of a segment. Or it means something's been bisected. A line has been bisected. So just like the word length, when you hear the word length, your brain has to say, oh yeah, I got to do the distance formula. So when your brain hears the word center, they have to use the midpoint formula. And if you look down here, here's my midpoint formula. Okay. But notice I'm not subtracting them. Notice I'm adding them. Notice it's parentheses and a comma. Where have we seen parentheses and a comma before? That's an ordered pair with an x value and a y value. And it makes sense that this is always an ordered pair because midpoint, it's a point in the middle. That's how you can remember it. So if I come down here and I look at this first example, where would the midpoint be? The middle of this, if I just eyeball it, that looks like the middle. And I could count very easily. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. I believe that's the midpoint because just by counting it looks like it's in the middle. But if I use this formula, I'm going to be able to algebraically prove that this is the center of my line segment. Okay? And you do it just like you did the distance formula. You just plug it into this formula instead of the distance formula. So first thing I'm going to do, write down my ordered pairs. So I have negative 5, 3 for A, And I have 3, 3 for b. So all I do, set up my formula. So I'm going to come over here so you can see. So negative 5 plus 3 divided by 2. And 3 plus 3 divided by 2. From here, I do the rest in my head. Negative 5 plus 3 is negative 2. Negative 2 divided by 2, negative 1. 3 plus 3 is 6. 6 divided by 2, 3. So my midpoint is negative 1, 3. And if I go to plot negative 1, 3, notice it is that point that I plotted. Okay? Now I can't say this equals m because we've already used m as a variable. The variable m is for slope. So usually if I'm talking about midpoint, I just say mid equals. There is no designated variable for the midpoint. Okay? So if we do one more example for midpoint, the middle of this line segment, I bet, looks like it's right here. Okay? Again, I'm completely eyeballing that. So now I'm going to prove by using this formula. So the first thing I'm going to do is write down my ordered pairs. So I have negative 5, negative 3. And here I have 5, 1. Alright, so set up my formula. x1, which is negative 5, plus x2, which is 5, divided by 2. And then y1, which is negative 3, plus y2, which is 1, divided by 2. Do the rest in your head. Negative 5 plus 5 is 0. 0 divided by 2, 0. Negative 3 plus 1 is negative 2. Negative 2 divided by 2, negative 1. So if I come down and look at this point, sure enough, that's 0, negative 1. That's my midpoint. I'm done. Okay. So you have learned 3 formulas. Unfortunately, you have to memorize all 3 of these formulas. They're not given to you. But fortunately, they all use x1, x2, y1, y2, so you just have to remember the patterns. Distance and slope look a little familiar because you subtract them. Midpoint is completely different because you add them. So you do have to memorize these. I understand that this stuff isn't necessarily hard, more so than it is obnoxious, because they take a little bit of time. But try the best that you can. We will go over more of this on Monday in class, and I hope everybody has a fabulous weekend.